Okay, so this is the first chapter in physics in the textbook also about the physical quantities, units, and measurement. So this is the syllabus document of what is required. So you realize that this syllabus document, this is quite similar to the learning outcome you can see in the guidebook or even the notes. Again, the base quantity is all given here, 6 of them. The prefix also given here. Means that all these are very important. Now this one I will take note. Need to take note of this one. Now look at this. This one. Very funny. This question come out so many times, over the years. Combined size, pure size, come out. Show understanding of order of magnitude. That means from small to big, ranging from atom to the earth. They really ask you what is the size of the earth. Like how many, 10 to power how many of a meter. Then people cannot remember. But you need to remember what is which dimension is it? How big is it? You know what I mean? Like maybe from nano to mega, very big. You know what I mean? Yeah. So all this thing, based on this thing. So when we do the area, I mean, we go to the content, I will go through this thing with you. So down here, let me see what else. You also need to know the instrument, how they actually, what kind of instrument can be used to measure what kind of quantity. You need to know. All right. And then you need to understand vector and scalar. Have you learned vector and scalar?
Yeah.
It could be on either the first part, or it could be the next topic. Okay. Now here, okay, after that there will be kinematics. Under kinematics, you learn these things. I think we'll also be going through anyway later. So we have speed, velocity, acceleration. What's different between speed and velocity? Okay, and what is acceleration? And analyzing graph of motion. So you need to know formula like average speed equal distance over time. All right, that's what you can learn. You talk about acceleration, uniform acceleration, how to find acceleration, how to identify non-uniform acceleration, curve, and so on. All right, and then based on the shape of the distance time graph, shape of the thing, you see, they tell us exactly what you need to know. Based on the shape of distance time graph, shape of the speed time graph, you must know whether the object is at rest, moving at uniform speed or non-uniform speed, and so on. So these are the requirements you need to know. So once you can understand all these things and explain, you're okay already. Then calculate area under the graph to determine the distance traveled. This one, of course, we'll study this. And you realize this one, state. Whenever syllabus document says state or define, these two words, state and define, means that you just memorize the facts. State the acceleration is 10, approximate 10. So you need to know that, state means you need to know. Okay, even if I don't give you, you need to know. Gravitational acceleration is 10 meter per second square. You can understand? Yeah. And then that's it, done. These are two topics. So it's not difficult. So this table document, I send you the link. You can always go there and take a look. Right. If you want, you can just click download. Okay, let me move on. The name is like that, 50686 actually. Yeah, let me just put it outside. Later, I can just drop it to you if you want it. Desktop. Drop. Okay, I close this. Let's go back to our notes. Okay, so since we went through the syllabus because I want you to know that all these guidebooks, textbooks, they are aligned to the syllabus. So if you study accordingly and you know all the learning outcome, you're already ready for exam ready. Okay? So as introduction here, we need students to understand that, what's physics actually? Physics is actually learning about how to explain the things around us. A lot of physical things around us. You see that? Physical things. Like for example, why is it you feel hot outside under the sun? Why is it that when the wind blow you feel this way, kind of thing? Why is it that apple drop from a tree you drop vertically down, it doesn't drop fly sideways and so on? So all these are using physics like gravity and so on to explain. All right. So everything we explain around us actually can be explained by physics. If something you cannot explain by physics, for example, something just float and start moving. We call it metaphysics, right? Spiritual already. Yeah. So physics about physical world. And then because all these are in the physical world, we have something called a physical quantity. So the keyword is physical quantity. Okay? It's a quantity that can be measured. We can measure how hot, how long, how far, how high. Okay? Yeah, how loud, and so on. So now here, all in all, you just need to memorize this one. I will color all over. Highlight just now already. The 6 base quantity that you need to know. Okay, and the SI unit. And take special note of these two. Why? Can you tell me why these two are so special?
I'm not sure.
Capital letter. You cannot use a small letter. Remember, Kelvin small letter is wrong.
I see, I see.
Anything else, don't use capital letter. Don't go and do like that. Don't go and use like that. Don't do this. Don't write properly, kg like that. And then things like ampere. Ampere, of course, you know lah. Ampere people will not forget. Current, very easy. But Kelvin, a lot of people write that. And this is wrong. This is considered small letter. I just taught my Sec 2 student today. Because they're not careful, you know. Okay, so let's move on. This one need to memorize, yes. Okay, I tell you what. Since it's so important, I really need to memorize. I will ask you next time. So what I'm going to do is I send you this particular page like that. Okay, if it's too much, then maybe I shouldn't send, but never mind. Just send you a few critical one. All right, next one. Now, all these are derived quantity. If you don't know the word derived quantity, as long as it's not base, it must be something else. So it's just called derived. But I don't think they ask you for the word. So derived quantity derived from the base quantity. For example, area is length times width, volume is length times width times height, speed is distance over time. All these are derived one. And derived quantity has a derived unit. So if you take length times width, of course, it's length times length in a sense. Okay, so it's a meter square. So all these are the derived units. All right, so let's look at this one. What's wrong with this thing here? 20 meter per second. What's wrong?
They are dividing.
Yeah, they're dividing. Nothing wrong with dividing. There's nothing wrong with dividing, but you cannot have divide and yet this one. Because the meaning of this already equivalent to this. This is already inverse already. It's already below already. So you cannot have both a slash and an inverse at the same time. Okay, so it's either this or this, but not this. So these are the common errors we'll make. The density, what's wrong with this?
They have both the same.
Same mistake, right?
Yes.
If you have a -3, it means below already. There's no need a slash, right? Yeah. Okay, so now we move on to the physical quantity, the standard form. Are you familiar with standard form?
I think so.
Okay, standard form is in the form of A times 10 to the power n, where A cannot be less than 1, but it must be a single digit. So A is either, minimum is 1, all the way to 9.99999. Okay, it cannot be 10, cannot be 2 digit. Okay. And then the power will be here. So for example, this case, how do you do this? Look at this, just go through in case. In order to change this to standard form, you move decimal from here, 1, 2, 3, 4, right? So it's 3.09. Wait, 1, 2, 3, 4. Why is it 5? 4, sorry. I found a mistake. Okay. You shift 1, 2, 3, 4. So 3.09 times 10 to the power 4 already give this one. No need 5 already. Okay, try the other one. 1, 2, 3, 4, 5, 6, 7, 8. This is correct. This one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And this is correct. Because it go the other way, it's very small number. Okay, okay, so what is the atom size? Atom is about 10 to the power minus 11, this kind of dimension. Yeah. Anyway, so these are the things you need to know. Conversion. By the way, this one you need to memorize also. So I will put a star here. Unfortunately, yes, need to memorize. I tell you what's a common one. Very common one is this mega. They like come out mega. And they like come out giga also. Okay. And the other one is nano also possible. And micro. These are the few. Happen to be 6 and 9. I don't know why. Because the mini, centi, deci, kilo, we are very familiar already. So they unlikely to test around here. They test a bit beyond, which is micro, then nano, or mega, then giga. And take note of the size. The bigger one has capital letter. See that?
Yeah.
Take note of this. Yeah. So take note of this. Okay, this one is very important. I need you to memorize this. Okay. Tera Tera actually in the past is not so common we use, but nowadays a lot of computer memory, 1 terabyte, right? 1000 gigabytes, 1 terabyte. It's so common that everyone need to know already nowadays. Okay, so I'll put this check for you. Okay, that's it. Right. Okay. Oh, okay, very interesting here. In the 6 SI units, things like meter, second, kilogram, Kelvin, mole, and ampere, these are 6 basic units. Do you realize that only kilogram has a kilo in front? Instead of letting a gram, instead of making gram the SI unit, they make kilogram a SI unit. 1000 gram is SI unit. The rest are not. You don't see kilometer, you don't see kilo ampere, you know what I mean? But kilogram there is. This is the only one that has a prefix. Just for information. Okay, this one is very common also, conversion. This one I need to really understand, not just memorize. If I have a square, the square is 1 meter by 1 meter. Can you tell me how many cm square are there?
4.
Cm square. The area is 1 meter.
100.
The area is 1 meter square. I want to convert to cm square. How do I do it?
100 times 100.
It's 100 times 100. Because 1 meter square is 1 meter equal to 100 cm, right? So 1 meter square, you do this. Look carefully what I'm doing. I'm going to put a bracket, square, bracket, square. So I'll end up 1 meter square. I square the 1 is still 1, right? But this side become 10,000 cm square. See that? Yeah. Okay, must know that. All right. Okay, let's move on. Okay, this question is very interesting. Which one is bigger? A dust particle of 150 micro. In case you haven't recognized that, this is called micro. Micro means 10 to the power minus 6. Okay, you can memorize. Have you memorized? Not yet, right? Not yet. Okay, next time you memorize, now I help you. Okay, so if you remember, you know micro is here. Micro is 10 to the power minus 6. Nano, 10 to the power minus 9. Mega, 10 to the power 6. Giga, 10 to the power 9. Memorize this micro first. So micro is used here. Micro is like a U. It's like a U like that. Okay, small U. 150 micrometer or the filter of this size. Which one is smaller? So we have to convert both into meter to compare, right? Okay, so how do you convert? How do you put the micro thing? Carefully what I'm doing, Okay, never mind. Anyway, they do already here. Okay, micro, straight away the word micro is converted to this. Do you know that? And then you realize that 150 is not the standard form. So I make 150 into 1.5 times 100. You see that? Yeah. And then the next step, you combine these two together. When the base is the same, the power add together. I'll show you. AM times AN is same as AM plus N. So when you multiply 10 to the power something, 10 to the power something, right? You realize that you just add the power together, that's all. Okay? You give me a second, I got a call from school. Okay, so this is the indices. If you have this power multiplied by a power, do you know how to multiply them? Have you learned already? Algebra. 10 to the power 2 times 10 to the power minus 6. How to combine them together? If you don't know, you can press calculator, it's the same. Then don't have to worry so much. But basically, the idea is when it's the base 10 is the same, the power just add together. I give you the formula is that add together. So 2 plus minus 6 become minus 4. So this become the new dimension in terms of meter, converted to meter already. Okay. Now, the next one is the filter hole, which is 0.0015 cm. And this one, you shift decimal. Look carefully, I'm doing. I shift decimal 1, 2, 3. So it's 1.5 times 10 to the power minus 3. Okay? And centi. From centi to meter, centi is 10 to the power minus 2. Centi is 10 to the power minus 2. So you add another 10 to the power minus 2. Okay, when you come to a meter. And then you add the power together, minus 3 minus 2 is minus 5. So you realize that, hey, this is a 1. Then we look at this and this. Which is smaller? Both are 1.5. Which is smaller?
10 minus 5.
Minus 5 is smaller, right? So therefore, the dust particle is smaller than the filter hole. And therefore, this filter can be used to trap the dust. If this hole is larger than that, then it's not effective anymore. Can I say? Okay, good. So this is about conversion. Okay. All right. So down here, okay, nano. Now, can you remember what is the size of nano? Nano is how many? 10 power?
Minus 9.
Yeah, minus 9. So it's 10 times 10 to the power minus 9. But if you want to put into standard form, okay, so standard form will be what? It will be, okay, this one change to millimeter. So you want to compare this nano into millimeter. First, you convert to meter. Another way is convert the milliliter mm to meter. Then you can compare, right? Or they want to know how much larger is the human hair compared to the microchip. How much larger? So in other words, I want to compare this. If I convert this to mm, how many mm is that? So what they do is minus 9 is as good as minus 3 and minus 6. And minus 3 together, 10 to the power minus 3 m is as good as 1 mm. See that? Milli is here. So this one become milli. And this feature here is 1 times 10 to the power 5, 10 to the power minus 5 mm. Okay? Then you ask yourself, the hair is 0.1. This microchip is this one. So you take the hair divided by the microchip. Hair divided by that. Okay, down here, actually, they shouldn't use this now. They shouldn't use this. You know what they use? They use the hair 0.1. They should divide by this. They should use 10 times 10 to the power minus 5. Like that. Is it okay? Now, how do you shift this thing? Of course, the fastest way you know how to do, never mind. Press calculator. Because they are both mm. So you press. Okay, let's try a calculator. Do you know how to press 10 to the power minus 5? Do you have this button at the bottom? 10 to the power something, right?
Yeah.
Yeah, okay. So you press 0.1, then divide. Then divide by 1, then you press this button. 1, then this button. Then press the minus 5. That's all. Then equal. You should get 10,000. Do you see my this thing? Display.
No.
Can you see? So I press what? I press 0.1. Then I press divide button. I press 1 button. I press the 10x button. What is it? Then I press the button is minus sign. Then I press a 5. Then press equal.
Yeah.
You got it?
Mm-hmm.
Yeah. So you must know how to press this feature. So it's 10,000 times. Okay, that's how you do it. Okay, good. So this is a application of conversion. Then this is the one that you need to know. Diameter of an atom is about 10 to the power minus 10. Yeah. And then the magnitude order is minus 10. Okay, order of magnitude minus 10. Earth is 6. So you see this, minus 10 and 6. And this one must memorize one. Unfortunately, must memorize. The full number no need, but you must know it's 10 to the power 6. An atom is 10 to the power minus 10. You need to know one. Okay. I saw before, some years they will ask you, some years they'll give you like that. They give you like a large number, they ask you what's order. For example, like they give you a number like that. Then they'll ask you, which order? This is under mega, right? Under 10 power 6 mega. But if they don't give this number, then they expect to remember is mega. Okay, 1 year came out of that. I can't remember which year 1 year came out of that. All right, so must remember this number. Atom, -10. Earth, 6. Okay, so now we go to physical quantity, measuring tape. All these are measuring length. So measuring tape is for long measurement. Meter rule, learn the spelling, meter, M-E-T-R-E. This is a measurement, not M-E-T-E-R, it's M-E-T-R-E, 1 meter, meter rule. Digital caliper, you need to know how to use. I'm sure your school will let you try this one. Yeah. And then remember, always set to 0. There's a button here. There's a 0 button. Always set to 0 first. I think the button is here. Set to 0 first. Okay. Then the micrometer screw gauge. I'm not sure whether the school let you use this one. Do you use this? Not all schools show. You have okay. It's for very small object, less than 2.5 cm. Small one. Okay, this one is 15 cm. So you may want to know this is up to 15 cm. This one is 2.5 cm actually. Okay, for small objects. Good. So now here, you talk about certain precision. How far can you measure until? For example, you can measure the measuring tape is up to 0.1 cm. And then digital caliper 0.00 is a 3 digit of a cm. This micrometer screw gauge is 4 digit of a cm. Okay, and this is less than 2.5, 15. So you may want to remember some of these values. They do ask. For example, why is it I cannot measure the diameter, the width of my handphone using micrometer screw gauge? Because this is larger than 2.5. I cannot use. Must know that. Okay. Right. Okay, so I won't go through this. Let me see. Okay, maybe I should just run through this one. This one in case you don't know what's a precision. So let me run through the precision itself. Okay, let's see. The user guide of this thing states that precision is this. Yeah, this is based on user guide, which is just how we look at it. Okay, micrometer, digital micrometer screw gauge is 4 decimal place of a cm. The range is 2.5. The measure diameter of wire, the wire is this value. So because you can measure up to how many? 4 dp, right? So you realize you only can measure up to here. See that? Up to here. Okay. So in other words, you can't measure the last digit here anymore, because if this is the edge, because my meter can only read 4 decimal, how does a person have the last decimal? It's not possible. Not possible. So when you read a time, it's either 1.5264. The next reading that appears is 1.5265 already. Then furthermore 1.5266. So there's no way to have a 2 behind. That's why this is wrong. Impossible. Is okay? Yeah, because minimum is here only. And then recording this one is here. Is it possible?
Yeah.
The size, dimension, maximum is how much?
2.5, so it's not.
Not possible because it's larger than the width of the gauge. You cannot measure more than 2.5. Maximum 2.5000. Is it okay? Yeah. Okay, so it's too long, cannot. So this is something that you need to take note. Okay, parallax error. Parallax error is we position the eyes, inaccurate position of the observer's eyes. So you must be positioned directly above the marking. So the keyword is eye should be positioned directly above the marking. Okay. If you see in any angle, you realize it's like that, the reading is not accurate anymore. Okay. And the zero error is error of the machine. Non-zero reading when we expect a 0. So they call zero error. So what do you do with zero error? You can minus away the zero error, or you can actually set to 0. You press the button, set it to 0. It's okay? So you can always minus a 0 error. For example, I have a reading 0.5 gram before I weigh anything, 0.5. It's a positive 0.5. So if my measured one is 10.6 gram measured, so I must minus 0.5 equal to 10.1 grams. So it wasn't as heavy as 10.6, but because of the zero error, that's why I must minus away the zero error. Can I say? Okay, so a pair of digital caliper gives a reading of minus 0.2. The zero error is 0.2 negative, and 3.5 mm when it's measuring a width. So what's the zero error? Zero error is a negative 0.2. Remember, negative. But you always minus zero error. Look at this. It always minus zero error. So it's 3.5 minus my zero error. So end up 3.7. Are you with me? You always minus zero error. So if the zero error is positive, you minus just nice. If zero error is negative, you minus, you add it back. Also just nice. Can I? Okay, so why is zero error? Zero error is because of wear and tear. Just remember, I didn't go through the detail, but now you need to know, due to wear and tear, okay, at the zero end of the ruler or instrument. So if you use electronic balance for too long, maybe inside there, there's a misalignment. So you need to press the word tare, T-A-R-E, to set to zero before you measure. Okay. All right, next one. Measure time is stopwatch. Time is stopwatch. You use digital stopwatch, of course. Pendulum is also able to measure the time. Okay. For example, okay, not pendulum. I mean, you can measure the time of pendulum. So pendulum swing is a forward, then backward. This is called one oscillation. Like here, then back is one oscillation. Okay. So the time taken for it to have a complete swing is called a period. I'm sure you've done this experiment in school, right? Do you? Yeah. Okay, usually it's quite fun actually. So you realize that we do the experiment, what do you change? What do you adjust? What do you vary? What's the sorry?
The length.
Yes, the length. So when the length becomes longer, what happened to the period?
It becomes shorter.
The length longer, shorter, right?
Oh, wait, can you repeat?
When the length of pendulum longer, does it swing take longer, the period longer or shorter?
Take longer.
Take longer, right? Yeah, correct. Period is longer. So you can use the stopwatch to measure. So if you do this experiment, remember you swing back and then completely back to same position, then you take the what do you call it, the time for the swing. But you do any experiment, it's always good to take average of many readings. So I swing 20 times, then divide by 20, that'd be more accurate. This is just a skill, all right? All right. So common error, if you do this experiment, make sure it doesn't swing sideways, it doesn't go round and round. It just swing along a plane. Okay. And the angle must be small oscillation. Okay, this one I think I wouldn't go through this thing now. Okay, let's see. Okay, now go to vector and scalar. So you must remember vector and scalar have a very specific definition. Scalar means has a magnitude but no direction. Vector has a direction and magnitude. So let me give you an example. The car can move like this, right? Move from here, travel here, or like this. All these are actually, this is just, let me see, this is the distance move. But if you want to talk about displacement, that means from beginning to end, this is the displacement. Okay? Yeah. So the distance travel can be anywhere, but displacement is always the shortest distance between the 2 points, starting at the end. Okay, give you another example. If you go towards the north, 5 km, you go to the, okay, use 2 better. 2 km to the north, 2 km to the east, 2 km to the south. How far have you traveled? What's the distance? You travel 2 km up, 2 km to the east, 2 km down. What's the distance travel?
6.
2 plus 2 plus 2 equal to 6 km, right? How about my displacement? Displacement means what is the ending point compared to the starting point? Answer is 2 km, the blue color. You got it? Yeah. So displacement has a direction. The distance doesn't have direction in this case. Okay, so displacement is a vector. This is a scalar, just a quantity without direction, but this has a direction. Okay, Then speed. Let's say you take let's say it takes 2 hours to travel. Then what is my speed? My speed equal to 6/2, 3 km per hour, right? But my velocity is displacement over time equal to 2/2 equal to 1 km per hour. And this is towards the east. There's a direction. So if I use distance travel, regardless direction, the total distance travel over the total time, I get speed. So my average speed is 3 km per hour. But if I talk about displacement, I'm moving towards my east at the speed of at the velocity of 1 km per hour eastward. Okay, that's all. Can you answer the difference, right?
Yeah.
Okay, good. So this one has a direction, so it's called a vector. And the top one is a scalar. Scalar means only a value, no direction. A vector has a direction as well as a value. Can you say? Okay, good. All right, let's move on. Now, how do you add? Okay, how do you add a plus and minus scalar? Very simple, just plus and minus, regardless of direction. But if you are a vector, then there's something called vector addition and subtraction. Vector. What do I mean? For example, if I move this way and then I move it exactly the same way, what is my displacement? I back to origin. Displacement is 0. See that? Because going forward is plus, going backward is minus. So vector has a direction. So if you take forward as positive, then the backward must be negative. Okay? So you even can use like that. If the vectors are not parallel, as a direction like that, then you can do vector addition. For example, if the person move like that and then move like this, the final overall is here. The resultant is here. So from one end to the end, tip to end. Okay, the vector addition. Okay, let's move on. Okay, let's try this question here. So a man goes hiking in the forest and walk 300 meters towards the north. So you draw 300 meters to the north and further 400 to the east. How far is he now from the starting point? In other words, how far is he from the starting point? Now, because this is a vector, okay, you can draw it out by scale. For example, I use 1 cm represent 100 meter. So I will have 3 cm, right? 4 cm. If you draw exactly north, then east 3/4, you end up a 5 cm diagonal. Imagine it's a diagonal 5 cm. And because 1 cm represent 100 meter, so 5 cm represent 500 meter from the starting point. That's how you use the scale to draw, scale drawing. Is it okay? Okay. Of course, if it's a right angle triangle, you can use Pythagoras theorem. The Pythagoras theorem, the diagonal square equal to the side square plus side square. Do you remember that? Like that. A, B, C, the longest square is equal to the other two sides add together square. Like that. Okay? Okay, let's move on. All right, so sometimes they may ask this question, so you have to learn properly. For example, down here, let's see. Okay, when you add two vectors together, for example, you have 8 cm towards the right, 5 cm towards the right. So the total is actually 30 cm, 13 cm towards the right. 1, 2, overall become this one. See that? On the other hand, if you have 3 cm to the right, 5 cm to the left, how will it become? It's strange, right? Let me see. It's not like that. Oh, no. Okay, I better show that. This one means this one plus this one become the resultant. Okay, green is resultant, huh? This one minus this one, then the green is the resultant here. I move forward by 8, I move backward by 5, I'm effectively moving forward by 3 only. But if I move forward by 8 and then further 5, total I move 13. That's what they try to say. It's okay? Yeah. Now down here, this is a trick question. Now this one is very important. Now, if I have two vectors, 8 and 5, I can add anywhere I like. What's the maximum value and minimum value you get by adding these two vectors together? Answer is here. Why? Because I move by 8. Look at this, huh? This is 8, huh? And then I move back by 5. So how much did I move? I actually move by 3 only. You see that? Okay, huh? On the other hand, if I move by 8, and then I move another 5, my total is actually maximum 13. So when the two vectors are going against each other, they will go to the smallest value, which is the difference between them. If both vectors are moving in same direction, the sum of them will be the total, which is the maximum. So do you realize I got minimum and maximum now? So I know that the factor could be from between 3 up to 13. This is overall. Is it okay?
Yeah.
So always remember two sides. When they are totally opposite each other, they cancel each other out and there's still a 3 left. But they're both in the same direction, whether it's to the left, to the right, or up or down, as long as they're both parallel, same direction, maximum you can go is 13. So it's not possible to be 14, not possible to be less than 2. But anywhere in between, I can reach. All right, let's move on now. Okay. All right. Okay. Look at this. This is a question that we are testing you. See whether you can answer this question. What's the minimum you have?
Minimum 2.
Yes, because you move by 3, then move back by 5, actually you're moving by 2 only. So can it be 1?
No.
No, cannot be. Can be 2, can be 8, right? Why 8?
Because you can move by the same direction.
How about 5.83? A decimal, can or not?
No.
You can. You go like that, and then you go like that. So this distance is somewhere in between. It can be any angle, it can be any length, depending how far I open out the angle. This one may not be whole number, can be decimal. Anywhere between between 2 point something until maximum up to 8 in between. Is okay? Very good. Oh, and we're done for the whole topic already actually. Okay? So far okay, huh? Okay, good. Let me just stop this one. Of course, the question later I send this whole thing to you. You can try the question at the back. All right? Yeah, you can try. Okay, let me just stop this thing.